Okay, what is the core of the Earth made of? Chris? Iron and maybe some nickel, right? And the core has two parts. And what are they? The inner core and the outer core. The inner core is, you say? Solid. Outer core is liquid, molten metal, and it can flow. So as the Earth rotates, hurtles through space, the motion may cause some movement in the liquid outer core. And when you have metal flowing, then you may have some electrical charge moving through. There are two theories that scientists are still debating about why we see the effect that the flowing melted metal of the outer core and the solid inner core form essentially a magnetic field around the Earth, like the Earth is a big giant magnet. We'll look at making electromagnets here in a little bit to try to kind of demonstrate the effect of flowing charge around a solid metal core. But does anyone know what the two theories are about why we have a magnetic field? Bethany? The dynamo theory. And, Duchesne?
The rapid decay theory.
Rapid decay theory. Okay, so the dynamo theory is kind of the most popular theory today. And why does the dynamo theory predict that we have this flow or this charge flow in the outer core? Anyone know? Okay, so think. We have a temperature difference between the inner core and outer core, right? We find that that temperature difference, also, of course, the mantle would be here, temperature difference. So the outer core will have a flow based on the movement of energy because there's a temperature difference here, 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 right? We'll get a convection set up. It flows from areas where it's hot to areas where it's cool, cools off, and continues to flow. So we get this flow causing an electrical current in the outer core, and then as the charges flow around the solid, we essentially form an electromagnet, which you'll see in a minute. Rapid decay theory says that the electrical current is a result of the way that Earth was created. This is not the most popular view among scientists, but it is a view that allows for some prediction. If you use this theory to do some math, you may see that planets that we were unable to observe the field of, if you use the rapid decay theory, you find that it can predict whether or not a planet has a magnetic field and what that field would be to a much greater degree of accuracy than the dynamo theory. Now that we're able to observe the fields of different planets, we see the rapid decay theory is better at predicting, so that lends some credibility to it. But scientists still favor the dynamo theory. Because change is hard, I guess. I don't know. But the rapid decay theory tells us that we know that there's resistance, right? If I throw a ball over there toward Elise, we're going to see it'll slow down because of air resistance, right? If I push this book, it'll eventually stop because of friction. And when you have a flow that's set up that doesn't have anything adding to it, it will slow down and eventually stop. A current flow will stop because of resistance. Friction, air resistance, and the resistance of the current flow are all physical laws that we see apply everywhere in the universe. So with the rapid decay theory, we would eventually predict that the Earth's magnetic field would dwindle down to nothing and then actually stop. So time will tell, I guess, but it would be a lot of time. Either way. We also see either theory can allow for magnetic field reversals in the Earth. And we observe in nature that the magnetic field of the Earth has reversed multiple times. And the way they can observe this is that in certain rocks, magnetic elements tend to line up with the Earth's field, right? So if a layer of sediment is being formed, laying down on the bottom of the ocean, or dust settling, or whatever, anytime you have layers of sediment forming, any magnetic particles will align themselves with the Earth's magnetic field. We know that magnets have a north pole and a south pole, right? And so we find that in rocks, sometimes the magnetic elements found in rocks will be aligned opposite to the field of the Earth, which means that when they laid down, the Earth's magnetic field was opposite of what it is now. And we find layers of rock where magnetic elements are pointing north-south, where north is this way, and then maybe a few layers later we find that north is now pointing this way. And we have observed other heavenly bodies with magnetic fields actually experiencing magnetic field reversals. And in fact, they predict the sun is experiencing one right now. And it takes a long time to kind of crunch the data. It may have actually already happened. It may happen within the next couple of years. Maybe we'll find out more about that as this year progresses. There was a lot of news about it toward the end of last school year that they think that might have been when it happened. The sun has reversals, and people are actually talking about potentially the Earth is in a reversal cycle right now. But either the dynamo or rapid decay theory can allow for reversals in the magnetic field of the Earth from the North Pole being this way to the North Pole being this way. So, kind of interesting.
Well, how can they switch?
How do they switch? Well, yeah, we don't exactly know a whole lot about that. The field reversal is kind of complicated. So,
if the sun is moving the same way, it's like if the Earth and the sun are moving the same way, if they both reverse, then how would we even realize it?
well, we can measure the field and we can see which way magnets line up. Like the compasses and stuff, we can see, how they line up. And we can tell which way the field is pointing now.
Didn't you say, in the book, it said that most scientists didn't agree with rapid decay theory because it would imply that the Earth is really young?
Perhaps, and also because the field is intrinsic in the way that the Earth was created. And anytime you talk about creation, that can be a sticking point for most scientists, that immediately disqualifies a theory from being considered, because if something depends on how the Earth was created, it can be a problem. But yes, that would tend to be a more young Earth theory. Either way, whether it's by temperature differences or as a result of the way the Earth is created, number one, it's pretty complicated stuff. And the math that goes along with it is something I don't understand at all, I promise. To figure out, for example, how to predict the magnetic field of Mars, I can't do that. But it is possible using these theories to do it. So that's, really interesting. And it's especially interesting to find that they were able, with the rapid decay theory, to predict the fields. And so if you have a test question like which theory do you think is best, you can answer that either way. I'm not going to mark you wrong. I don't hold a dogmatic view of either theory, Duchesne.
Which theory do you believe?
When you look at making an electromagnet and you look at the dynamo theory, We know that we have temperature differences in the different sections and even temperature differences throughout different sections, right? You know the mantle has a wide temperature range. If you look even at the thing we did last week, you can see the mantle has a temperature gradient of 500 to 4,000 degrees Celsius. The outer core 4,000 to 5,100 degrees Celsius, and the inner core also may have some sort of temperature gradient throughout. So you can see that if this is very hot, and this, though very hot, is cooler, that if you have a liquid there, it's going to flow, right? It's going to pick up heat from the inner core, flow up toward the mantle, because you know that when things are hot, they rise, and when they're cool, they sink because their density changes a little bit with that energy, right? So you're going to set up a flow. So I can see how the dynamo theory would work, because anytime you have flowing metals lose their electrons quite easily. And so you end up with a flow of electrons, and really all that electricity is a flow of electrons. Like if I take this battery, right, I've got a positive end and a negative end, and when I connect the circuit, like even my own body can close that circuit, right? Then I'm just allowing electrons to flow through the battery. And that flow of electrons not only creates an electrical circuit, but it creates magnetism. And really what it comes down to is electricity and magnetism are one force. They're the same exact thing. Light, electrons flowing for electricity, magnetic fields, all of those electromagnetic waves are the same. So I can see how the dynamo theory would work based on just the practical ability to use things like batteries, compasses, and magnets that I can observe. I don't really fully understand the dynamo theory, and I can't really find a good explanation of the depth of it anywhere. But clearly people are using it to predict stuff. So there is a good explanation. I just can't find anyone who can really lay out the details of it and the equations of it for me.
In a way for a regular-ish person to understand.
Right. So I think maybe it's hard to find because fewer scientists subscribe to it and there's not as much written about it. Or maybe just because no one will publish it because it may indicate that the Earth is young, or some of those rather unpopular with the press theories. But I really have trouble actually even finding out about it. And I've tried, but I'm not having any luck. If anyone actually finds some really good stuff about it, that would be really cool. I can certainly see how the dynamo theory could work. But that's not to say that the other one. I mean, rapid decay definitely predicts other planets' fields better. So, you can go either way with that, but I would be prepared on the test to pick your favorite theory and explain why you think it's better than the other one.
Well, it could be a bit of a mix of both. Like, could it? Like, the turning on the inside could be what's helping sustain the electromagnetic field, but initially the electricity was started by the creation.
It could, but then the theory predicting that it would eventually fade out wouldn't actually work. Yeah, I really don't know, but just be prepared with an answer. If it tells you to explain your answer on a test and you just write me like 3 or 4 words, that's not going to work. Next.
Didn't the book say that the dynamo theory also supports like a decaying magnetic field, but the rapid decay theory supports it more directly?
Yes, but with the dynamo theory, you'll really just get reversals, but the temperature differences will keep the flow going so that you'll never decay to no magnetic field. It also seems like since having no magnetic field would be absolutely incompatible with life, probably that wouldn't work out for us on Earth. Chris?
What happens if you don't understand anything at all?
Prepare yourself an answer before the test. I mean, the easiest answer would be rapid decay predicts exactly what the fields of other planets are, so that's a good theory. I mean, that's a really simple answer to give. That it's better at predicting other planets' fields, so it's probably right. Or you could say, like, the dynamo theory explains that the Earth operates like an electromagnet. I can observe an electromagnet, so that seems to work for me. I just want you to explain one way or the other. You don't even have to tell the truth. If you really believe rapid decay, but you feel more comfortable explaining dynamo, that's fine. Just so that you're explaining one of the theories and why you think it might be better than the other. That's all I'm asking. So, just to warn you about that question, which is a bit tricky, let's see. And we'll talk more about that as we go through the questions. But I really am not sure myself which of those, because they both really do have some strengths and some weaknesses, and it's really hard to find out a lot about the rapid decay. So, let's see. I meant to bring my laptop and show you guys a video. But I think I emailed you guys videos so you can watch.
Which one?
The plate tectonics one. So, what are the plates? Well, no, we'll just do that when we talk about the questions. It might be more efficient to just talk about the questions so we have time to elaborate. That's what we all want to do anyway. All right, let's do that. I don't have a chair. Here it is. How are you doing? Do you need that, and I need this. All right. And then we'll also go over how you use exponents very specifically for earthquakes when we do this. So, starting maybe study guide number 10. I think we stopped at 10, probably. I don't think we actually covered 10 last week, so.
What number is it?
This is study guide number 10 will be the first one. Okay. So, where is the magnetic field of the Earth generated? The core. This is study guide 10, and it's the core. Meredith, you get a much worse question. What causes the magnetic field of the Earth? So we've got two theories that we just discussed. You can pick one and ask Bethany the other one. You can pick dynamo or rapid decay. Okay, so in the dynamo theory, what causes Earth to have a magnetic field?
A big amount of electricity.
I think it's a different question.
I think it's
Oh, okay.
I was looking at my question too, and I was like, that's not.
Hold on. I have my book. I have a book, guys. Yes. Let's read the question. Sorry. No, I have the book that has the right question. And it says, what causes the magnetic field of the Earth? Is that, yeah. Okay. Okay, so electricity generated around a solid core, yeah. You just keep saying the core, you keep getting it right. It's like Sunday school answer, the core. I see. Then it asks a whole separate question about the two theories, which mine doesn't. So, Bethany, give a brief description of one of the two main theories, and then Chris can do the other one.
In the dynamo theory, it says that movement in the core creates the electricity, and in the rapid decay theory, it says that the electricity, when the current comes from how the Earth was created, and that it will slowly decline over time.
Right, so no specifics about rapid decay at all, which I wish we had some. I have not yet figured it out.
Description.
If anyone wants to try writing their final project about that, maybe you can find it. That's a whole topic of discussion. And remember, you can write a paper or you can just give a 5 or 10 minute presentation about whatever you did, including many, many facts. Or you can make a video. We had a really creative news broadcast last year. You can do a little project and present it, like a lab type project. So it's really wide open, whatever you enjoy. Chris, let's ask the right question. 13 says, what makes rapid decay more scientifically valid than dynamo?
They correctly measure the magnetic field of other planets.
Right. So that's an easy place to kind of go if you're asked something like that on the test. Let's see. Do you have more detail on that or anything?
Was that supposed to?
No, I just wondered. My question's a little different, so let me see if I can kind of put them together or make sure I'm not answering the next question. Okay, I'm good. So, over the last 150 years, what have we actually observed about the Earth's magnetic field? Bethany?
That it is slowly declining.
Right. So, if the rapid decay theory is correct, that's what we'd expect, right? Resistance would cause the decline of the field over time. But that could also work with the dynamo theory, too, because it could be part of the field reversal. And according to the dynamo theory, field reversals aren't just like, bam, I've reversed. They take place over a very long period of time, or sometimes a very short period of time. And they have kind of scenarios where either one of those could happen, a field reversal over a long or short period of time.
Could the field reversal affect the magnetic field? Like, could it,
It won't, we've never seen a time when the magnetic field of Earth utterly disappears, because that would pretty well kill everything. Like,
We've never seen that.
right,
but it
no.
affects it if it's like slowly decaying. Would it affect it and make it lessen?
Yeah, the magnetic field has gotten weaker over the past 150 years. And we don't know if it's as a result of a steady decline that will continue or the beginnings of a reversal, which we may see, and then the field may strengthen after it reverses, or it may reverse and then continue to decline, so we don't really know. And we haven't had the technology to observe this for long enough to actually see several cycles and kind of see what's going to happen. So, definitely an area of science where we don't have enough data. So we just have theories, but we don't know what the actual data is going to show.
Guys, when's
Yes.
the last time the magnetic field did reverse?
Well, it depends on who you ask. Because they're,
So complicated. There's a lot to it.
it's because when that, when the rock is laid down, right, and then the magnetic elements line up in the rock according to where the field is, right, and then another layer is laid down, another layer is laid down. Of course, many scientists are going to say, well, those layers take eons to lay down, right? I mean, old Earth would say that the different layers of rock are laid down over billions of years. So they would date the field reversals based on how old they think that layer of rock is. Young Earth would say, you know, field layers can be laid down very rapidly during a cataclysm like the flood, which we're about to talk about. And so it could be that something like the flood, at the beginning of the cataclysm, the field was like this, and then the cataclysm actually caused the field reversal. So the next layer, which was laid down very quickly, is actually pointing the other way. So, yeah, you could get a super wide, like it was laid down over the course of a couple months, and then we see that field reversal happening quickly, or over the course of billions of years, and we see several field reversals that happened over long periods of time. Nope. It really depends on where you're coming from with the age of the Earth, how you interpret the data that you see in these rock layers. So that's very complicated. And like I said, I give no answers here. I really want you guys to read everything. I mean, you've got to read old Earth Big Bang stuff. You've got to read old Earth creationist stuff. You've got to read young Earth stuff, and just kind of see the possibilities, because you can't know where you stand until you've really examined all the data. And it.
It's a motorcycle.
Oh, lovely.
They're pretty exciting.
I wonder if I don't
Dirt bike or motorcycle?
I rode on one.
Not now. You're not.
Not now, but
Okay, so.
Softest fault.
Oh. Let's aim over here for a minute. So, kind of moving in that direction, though. You could easily write or present a large project on this, and it is interesting, but I don't think that we can come to a real conclusion with the data that we currently have. And certainly scientists aren't going to agree on this regardless of the data we get, because, somebody has to be wrong here. The Earth is either this age or that age, and,
Somewhere in between.
well, it has to be a certain age, and regardless of what it actually is, even if we somehow found out, people would not want to know that. So, what are we on? 14. So, Jenna, get us back on track here. Why is a catastrophe like Noah's flood an essential part of Earth's history if the rapid decay theory is true?
Because the rapid decay theory states that the magnetic field can only reverse if a global
Cataclysm.
event occurs, like the worldwide flood, and the magnetic field has reversed in the past, making such an event necessary.
Right. So we know there have been reversals. If rapid decay is true, the only way to get a reversal out of rapid decay is for a gigantic catastrophe on Earth, like the flood. I have a terrible cold. I'm so sorry.
Catastrophe.
Right.
I don't think World Wars count.
No, because they wouldn't do the damage to, like, volcanic and earthquake type activity necessary to change the motion of the outer core that would change the field. So, Ava, what 2 reasons make otherwise good scientists ignore I cringe to even say, because I really want to stay neutral here, the more scientifically valid rapid decay theory? Right. So rapid decay predicts that we have a less than 10,000-year-old Earth, which most scientists would say is absolutely inconceivable. But remember that it's not like voting makes you right. So it's perfectly legitimate to consider theories that most scientists would disagree with. Lily, why would life cease to exist without our... Oh, sorry, Elise. Why would life cease to exist without Earth's magnetic field? And why would cosmic rays be bad for us? Yeah, they kill stuff. They're bad.
You don't want that.
Cosmic rays need to be deflected, and the Earth's magnetic field does that. And that's because, remember, electricity and magnetism are the same stuff. So, light, and not the kind of light you see, but the kind of light cosmic rays are that we can't see, and the Earth's magnetic field can repel each other. Close the window, it's too distracting. Too many interesting things are going through the parking lot today. So, Lily, 17, what are the plates in plate tectonics?
Plates are like islands of rock that float on the atmosphere.
Okay, and why can they float?